Hey everyone, and welcome to the second part of our video tutorial about how to work with OpenBallShock 2D program. In this session we are going to learn how to create the mesh of our simple geometry. So let's see how we can do it. As an example, I picked a very simple geometry. It's just a circular cylinder with radius 1. So let's push the next button and look at our grid generation box. We have a table with required numbers we're going to put, where we have the grid type section where we can put our type of the grid we want to put, algebraic grid or elliptic grid, and also we have the number of regions button, which theoretically creates the number of your subsections of grid to generate each piece. On the other hand, I haven't finished this feature, so the only option we have right now is 1, which is enough to create a good geometry of the grid. So let's go ahead and use it. So we click this button and we have certain things. We have x1 and x2 locations in the table, which are literally the leading edge and the final point of our characteristic length. Imax is the number of points along the boundary. Let's put 80. And Jmax is the number of points across the boundary. So it's outwards. Let's put 40. You can put any number. The more the better, but the more time you will have to spend calculating the solution. Grid height is overall height of your mesh including geometry. So line A presents the length. So let's put 5. And grid length is the length from the leading edge to your free stream, to the left. So let's put 1. Now, we have two types of grids, algebraic grid and elliptic grid. Algebraic grid is a simple straight line grid along the whole domain, which is very quick to generate, but sometimes it may cause some inaccuracy in solutions because it's a simple grid and sometimes it doesn't follow the free stream condition, not the free stream, the flow conditions sometimes. However, you have the feature of clustering in the algebraic grid in this program, which laterally shifts all your grid lines that are at the same have the same shape of the boundary closer to the boundary. So let's see how it works. The clustering term works between 1.1 and 10. So 1.1 is the clustering such that you approach the body surface, and closer to the 10 or 5 or more makes your grid lines go away from the body. So let's draw it. We can use the menu buttons to zoom and move our picture. So as you can see here, we have the following picture. The straight lines from the body distributed, and also you can see that these lines become more dense closer to the boundary, to the body surface, which is required for more accurate solution. Now let's look at the elliptic grid. Elliptic grid doesn't have clustering term, however it has a better meshing because it solves Laplace equation numerically, and the streamlines or the grid lines become more smooth. So let's take a look. It's going to take a while. We click the button and there's something going on the back of our screen. There are two numbers. One of them is called error t, which is the error from each iteration, and k is the number of iterations. So when the error becomes less or equal to 0.04, the solution will converge. And k will just tell you the number of iterations required. So depending on the grid size, the solution can be really fast or it can be not really fast. So it's up to you how many grid points you want to use and how accurate you want your solution to be. So we're almost done. And we are done. So let's see what we have. Comparing to the previous solution, we can see that the streamlines, even though it may not be that evident here, because our grid is kind of relatively dense, but we can see that some lines are slightly bended, and they're bended we don't have any major gaps in here in the grid, which is good. We're not going to have severe differences in our solution. So overall geometry looks, maybe it may look the same, but it's actually not really the same. It's going to be better. For more blunt bodies, it's definitely better than algebraic grid, but it's going to take a while. Let's try to put something more simple to see how really different it is. Say, let's put 50, yeah, and let's put 30, something really simple. Let's put algebraic grid. So just straight lines with huge gaps closer to the outflow boundary condition. And let's try elliptic grid. Let's see how fast it's going to be. And it's going to be pretty fast because our grid size is not big, just 50 by 30. Not that much of a grid. And here you can definitely see that the lines of the grid are curved and they're distributed better, at least closer to the body, which is definitely good because the most amount of crazy things happen close to the body, relatively close. So that's the feature of the elliptic grid. Now, there are a couple of recommendations I want to give you if you want to make different grids. You always need to be sure, if you're working with subsonic regimes, you want to have huge grid because distribution of pressure, temperature, and density are gonna spread along big domain. So it should be about 10 for this kind of circular cylinder. I would probably grab grid height of say 10 and grid length of 10 as well, so 10 by 10. For supersonic bodies, we don't really care about this kind of big domain because it's all about shockwave, but we need to make sure our shock has the outflow boundary condition of this side and this side. Not necessarily. Actually, the open bow shock 2D can give you outflow boundary conditions here. Yes, it can. On the other hand, if you make it such that it includes too many points, I'm not sure, but the code may give you some incorrect answers. But I'm not sure. If it's say 3-4 points out of 80 from each side, it's not a big deal at all. So always make sure you are far enough to ensure shock capturing. So the situation when your shock goes on across this line is called shock capturing method. It doesn't touch the free stream condition. So that's all about it. and I will see you on the next video where we quickly put our conditions and look at our results. And also I will give you a couple of suggestions how to treat the OpenBow Shop 2D. So see you on next video.